This is the video notes for Unit 3, Lesson 1. It's called Getting Ready for a Pool Party. In the launch, it shares with us the story of Sylvia. She has a small pool full of water that needs to be emptied and cleaned. Then it needs to be refilled for a pool party. During the process of getting the pool ready, Sylvia does 6 activities, each during a different time interval. So your job for task 1 is to create a story of Olivia's process for emptying, cleaning, and filling the pool. Number the activities given in the following table 1 through 6 to indicate the order in which they occurred in your story. Okay, so you're going to create a story down here using those 6 items. Now, the order doesn't really matter. Granted, there is a logical order. There's a few logical orders that can be used. You would definitely not fill the pool first, right? That doesn't make sense. It already has water on, or dirty water in it. So right now we are going to pause the video and give you about 2 to 3 minutes to create your story and put these 6 activities that Sylvia did in order. So I'm going to say pause video and create story. All right, now's the time to pause your video and create your story. How do you think Sylvia went through the process of emptying, cleaning, and filling the pool? Here's one possibility for her story. So I've labeled in the table 1, 6, 4, 5, 2, 3, and I've written the following paragraph. First, Sylvia removed water with a single bucket. Then she called some friends and they removed water with 3 buckets. At this point, they were tired, so they took a break. Then she decided, there's a faster way to do this. She got the hose and drained the water from the pool with a hose. At that point, the pool was empty. It was way faster than using buckets. So they decided, okay, it's time to clean the pool and then refill it. And that's how she got her pool ready for her pool party. So your order that you created could be completely different than this, and that's okay. As long as the order makes sense, you're good. So what we're going to do next is turn the page and we're going to create a sketch of the situation. And I'm going to pause the video again. So let's turn the page. You see this graph right here? It says sketch a possible graph showing the height of the water level in the pool over time. Be sure to include all of the activities Sylvia did to prepare for the pool party. Remember that only one activity happened at a time. Think carefully about how each section of your graph will look, labeling where each activity occurs. So this is going to be time down here, and then this is going to be water level. Okay, and then we are going to pause the video so that you can create your graph based on your story. So pause video to create your graph. So here's a reminder of my story, right? First was a single bucket, then the 3 buckets, then a break, then drain with the hose, clean the pool, and then filled with the hose. Here's the video that I came up with that represents my story. So I'm going to label each part now. So this part right here is kind of like a sudden drop with 1 bucket. So right here is 1 bucket. Here are my 3 buckets with my 2 friends helping. 3 buckets And then right here, I have our break. Here I have emptying with the hose. Here I have us cleaning. And then here I have filling with the hose. Okay. All right, so we've labeled up all the different activities that are happening. Now the next part is to talk about different places in the graph that are important and give them names. So the first important part of the graph is right here and right here. So that's really important because that's when the pool is full, right? So when the pool is full, we actually call that a maximum. So we're going to call this our maximum. And we have two of those, right? There's a maximum, and then here's a maximum. I'm just going to write max on the left side to make it shorter. When the pool is empty, right here at the bottom when we're cleaning, that's called a minimum. Okay. And then we've got different kind of slopes going on throughout, right? So this flat slope here, when they're taking a break, that's called a constant slope. And when they're draining with the hose, I probably should write that in here, draining with hose, then that's called a decreasing slope, right? It's decreasing, going down. And then over here where they're filling with the hose, let me add in that, filling with hose, it's called an increasing slope. Okay. All right. I'm going to actually pause this right here and we're going to go to our takeaways, because on our takeaways we actually are writing definitions for all of these vocabulary terms. So let's add a definition to our takeaways for maximum, minimum, constant, decreasing, and increasing. That way we have those already written in our takeaways before we introduce a few more. All right, going to our takeaways really fast. Some key features that we're seeing is the maximum, right? So that was the highest point on our graph. Highest point on a graph. Also the minimum. That was our lowest point on a graph. Okay, we also talked about constant. Let's see where constant is. I don't see it. I'm going to add it here at the end. So constant. A constant slope is where we have a horizontal line. It's flat. It has a zero slope. A zero slope on a graph I'm going to say line is horizontal. Horizontal. Okay, we also talked about increasing. So let's add that right here. It's the fifth one down, increasing and decreasing. So increasing was where we were filling the pool with water, right? That was when we had an upward slope. Okay, that's when our y values go up as our x values also go up. Y values go up as x values go up. Okay, and then decreasing was a downward slope. That's when we were emptying the pool with the hose. Okay, and that was when the y values go down as x values go up. Okay, so those are the 5 that we've identified so far. Okay, let's go back to our graph and see if we can fill in some of these others. So looking at our graph, I see one y intercept, right? This is our y-axis right here, this one. So our y-intercept is right here. It's that max on the left side. So this is also our y-intercept. Okay, we have a whole zone of x-intercepts. So when we're cleaning over here, here are a whole bunch of x-intercepts, right? So x-intercepts. Okay, so let's add those two to our takeaway list. So x-intercept is when y equals 0, right? That was all the way at the bottom where y equals 0. That's when we had our empty pool. Empty pool. Okay, and so that was our x-intercept. Our y-intercept was when we had our full pool. That was when x was 0. Full pool. All right. How many more do we have? Let's see. Okay, looks like we've got about 5 more. So let's look at domain and range now. You'll recall we've been learning about domain already. Domain is all the x values on a function. So I'm going to switch my color and I'm going to show what the domain is. So the domain is time, right? So it starts here at time 0 and it goes all the way here to when the pool is completely full again. So that whole interval is our domain. Okay, and then this is a new vocab term that you haven't learned yet. It's called range. So our range is our y values. So our range is from when the pool is empty to when it is full. So it's all this right here. That is our range. Okay, so let's add that to our takeaways. Okay, let's go ahead and add domain and range down here to our vocab list. So the domain, we already knew was the x values. So x values. In this situation, it was our start to ending times. Okay, our range, that's a new vocab term we've not seen before. That's our y values. And that is, for this situation, that's the water level, right? That's the empty to full water level. Okay. All right, looks like we've got 3 more. Okay. Let's look back at the graph and see if we can see places where it's continuous, discrete, or discontinuous. So looking back at the graph, okay, we definitely have places where it's continuous, right? Where all values are included within an interval, even the decimals. So I would say, let's do clue. I would say like right here, right here, right here, right here. It is continuous. I forgot to write over here where they're cleaning that is also a interval where the slope is constant. So let me add that right here. Constant. Okay. And constant. There we go. Okay, and then I don't think we have any place where it's discrete, where only certain values work, like we only have dots. But I did model the buckets as being discontinuous. Do you see that? There's like gaps in the data right here. This is considered like discontinuous. Okay, so let's go ahead and add some definitions for those three. So continuous is where all values within an interval work, right? There's no gaps in the data, even the decimals work. All values within an interval work, even decimals. And we would use interval notation to describe that area. Use interval notation. Okay, I'm going to skip to discontinuous right now. So discontinuous is where there's gaps or breaks in the continuous data. Gaps in the continuous data. And that we would also use interval notation for. Use interval notation. Okay, and then our last one was discrete. We know for discrete, only certain values work, like only whole numbers or natural numbers or integers, something like that. Values work. And we would use set notation for that situation, which is not going on here. Okay. All right. There are two more things that I need to talk about. So let's look back at our graph. Our key features vocabulary is looking awesome, so almost filled in there. So looking back at this graph, something that I did not point out was it's really important that when you're draining with the hose and filling with the hose, right, these two over here, it's really important that those have the same steepness. Like one is still decreasing, one is increasing, but they're they have the same rate, right? Because that's what the task one, when you created your story, it talked about how the hose drains at the same rate as it fills. So make sure you have like the same steepness for those two lines, even though they're going, one is a negative slope and one is a positive slope. All right, now our last topic is talking about whether or not this graph represents a function. So the idea of something being a function is really important. When something is a function, we only have one output for every input, meaning there's no overlapping of events. So yes, this absolutely is a function. So I'm going to write that here. Yes, it is a function because none of the events overlap. None of the events overlap. Like at, I don't know, 10 minutes, I'm only doing one thing. I'm not draining the pool and having a break. So none of the events overlap. And then it asks, would all graphs created for this situation represent a function? Absolutely. As long as you have none of the events overlapping. So yes, all graphs would represent a function as long as events don't overlap. Okay, so again, a function, there's one thing happening at a certain time, not multiple things. Let's give you that definition for your takeaways. So our last thing for takeaways says a relationship is a function if and only if every input, remember the inputs are the x values, has only one, this is like super important, output. Remember, outputs are the y values. Okay, so in context of our story, so every time, right, the x values are time, at every time you only have one water level. Like there's not multiple water levels because there's only one event happening at each time. All right, let's verify that everything is filled in for our takeaways. Yep, we've got our definition for function. We have all our key feature vocabulary. That's awesome. Okay, I'm just going to read our lesson summary. In this lesson, we created graphs to model a story context. We learned the mathematical words to describe the key features of functions. These mathematical words we are going to use throughout Unit 3. So we're going to start practicing them. We're going to start identifying them. These key features are used to analyze and compare functions. All right, that is the end of our lesson notes for 3.1. I wish you good luck on your practice.